Hi, and welcome back to day 3. We are on page 14, and today in this video, we're going to be talking about the 3 shortcuts that are available to us to prove that triangles are similar. And these are limited only to triangles. Up until now, we've had mostly triangles, but we've looked at some four-sided figures and circles and different things. These 3 shortcuts are only for triangles. So that'll limit what we're doing a little bit, which will make it a little bit easier for us. The first shortcut that we know about is often the most simple shortcut, and that's the shortcut called angle similarity. And it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So in this case, it says if angle A is congruent to angle F and angle B is congruent to angle G, then triangle ABC is similar to triangle FGH. And that's all you need. You just need 2 pairs of angles. So if you look at option A says determine whether the triangles are similar, and if so, write a similarity statement. So if you look, we can see that angle L and angle M are the same size because they're both 57. But when we continue to look at the triangles, we do not see right away that there are any other pairs. And so it's at this point that some people give up and say, no, they're not similar. But the thing that you do not know in both triangles is you don't know angle K and you don't know angle Q. And so we're required to try to figure out what those angles are to exhaust all of the possibilities. So if we switch over to Desmos and solve for the second side, what we would do, or third side angle, I'm so sorry about that, we would take these 2 angles, the 57 plus the 48, and we would add them up and subtract from 180. So that comes out to be 105. So if we subtract that from 180, we get the angle K is 75. Well, that's very convenient because if you look over here at angle P is also 75. That's very interesting. So angle K is congruent to angle P. I'm glad we didn't give up because now we have 2 pairs of congruent angles, and these triangles are similar by AA. That means that angle J and angle Q are going to be the same. And we can write our similarity statement. Triangle LKJ will be the way I'm going to do it. There's other ways to do it. And triangle MPQ. And we're done. Now, letter B, I will show you. It's a little strange. Most kids look at it and say, well, we have no numbers, so there's no way that these triangles can be congruent. Other students will look and say, yes, but wait, we have vertical angles. Or angle RSX and WST, however you want to name those. They're vertical. Isn't that one pair of angles, though? I mean, if we had another pair of angles, these could be similar. Now, what they're also giving you here are these little arrows. And I'm not sure if you remember, but those little arrows mean that we have parallel lines. And they're being cut by a transversal. So you can make XT your transversal, or you can make RW your transversal. I'll make XT my transversal. Make that just a little bit longer. And what they're trying to get you to see is that these triangles are actually going to resemble the picture that I just drew on the right. And if you look at, let's see, let me get a different color. If you look at this angle right here and this angle right here, we can label our B's and L's. These are alternate interior angles, and they're both L. So those are actually angles that are congruent. And the same thing would happen over here with the R and the W. So because these lines are actually parallel, we have some alternate, and I'm going to write it up here, we have alternate interior angles. Which means we have angle-angle similarity. So what I'm going to do is do some erasing because it's very hard to see what we're doing here. So that means that X and T and angle R and angle W, I'll write that down here, are congruent pairs. And they are similar by AA. Let's put a big AA here, and let's put a big AA here. And we'll write our similarity statement. Triangle SXR is similar to STW. It's just one way to write your similarity statement. So when you look down at the 1A and 1B, they'll be the same type of problem. And then we'll move into side, side, side. Now, side, 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 we have actually already shown you this. On page 13, when we did this the long way, and we did step 2, where we compared the corresponding sides and wrote one giant proportion, that's what you have to do to check side, side, side. So we've actually sort of already done that, which is kind of good. Now, what side, side, side says is that if the corresponding side lengths of the two triangles are proportional, then the triangles are similar. That means that the ratios have to have the same scale factor. So I'm going to extend my page just a little bit. When we look at these two triangles, you can tell that the small one is on the top and the bigger triangle is down here on the bottom. And remember what we did? We labeled small, medium, large, and we labeled small, medium, large. And then the next thing we did was we put the small sides together. So I'm going to take the small side on the top triangle, the small side on the bottom triangle. Then we put the medium sides together. The 6 is on top. The 15 is down below. Take the large sides, 8 and 20. And then we have to see, are these the same size fractions? So we're going to go over to Desmos. We'll do the first one, 5 divided by 12.5. And then we will do 6 divided by 15. The whole time we're looking at this decimal. See how this decimal is the same? So there's still a chance that these are similar. And then 8 divided by 20. And see here, 0.4 Or if we get a fraction, that'll be 2/5. There's our similarity ratio. And you have all three pairs of side lengths, which are proportional. They have the same scale factor. So now we have to write a triangle similarity statement. So this is what I do. Let me scribble this out here. We'll make this the squiggly. So what I do is I take the small side from both of them. So like R to S. So R to S, and then to the medium side, P, and then I go R to T over to the medium side, RTS. I think I did that wrong. That should be a Q. There we go. So R to Q to P should be R to T to S. So I take the small side and the medium side, the small side and the medium side. And that's the order that I put them in. R to Q, R to T, that's small. Q to P, T to S, that's medium. And then the large side is here, R to P and R to S. Now, the interesting thing about this problem, some of you may have noticed that we have vertical angles. This is also an example of the next shortcut, side angle side, where we have a proportional pair of sides and another proportional pair of sides with a congruent angle sandwiched in between them. So we can actually use either one of these for this particular example. Obviously, that's not going to be the case for every side example. But in this case, because we had vertical angles, it was either one. We haven't even talked about side angle side yet. However, you have enough of an understanding of a side, then an angle, and then a side from our triangle congruence unit that you should be able to see that. Okay, and then lastly, side angle side. If the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle and the included angle, see how angle S is in between those two sides, those red and blue sides, and angle Y is in the middle in between? That's what included means. Then the triangles are similar. So you have to have an SAS pattern for this to work. So let's take a quick look. This one I want to reserve for doing in class. This one 2B is just like the one that we just did, where we have vertical angles. We have a 10, which is small, a 20, which is small. We have an 11, which is medium, and we have a 22, which is medium. So this is an SAS pattern. I don't think here we could try SSS because we don't know the third side and we don't know enough information, like the lines have to be parallel to have angle. So we would have to try side angle side. So here I'm going to pair up the two small sides. So the 10 and the 20. And the medium sides, the 11 and the 22. That should be a 1. And then I'm going to type those into Desmos and make sure that they're the same scale factor. Most of you guys can see that those are going to reduce to 1/2. But if you can't, it's easy enough to just type them in and see that they come out to 1/2. So they are proportional. And we do have similar triangles. So if I was going to write a triangle similarity statement for this one, I would probably go from T to W, that's your small side, then to your medium side, just like I did before. So I would go T to W to M. That's my small side to my medium side. And then I'm going to do the same thing over here. I'm going to go small side to medium side, Y, W, X. And that's your 3 shortcuts, folks. Thank you for joining in. We appreciate it. And there is more practice. Like I said, I'm going to do this one in class. And then we have practice on page 16 and on page 17 and on page 18 that we'll be doing in class. And then when we get to day 4, we will be reviewing. Thank you very much.